Odyssey ware? Are you in Ingenuity?
Good afternoon. This is Mrs. Houghton, and we're going to be working on sine, cosine, and tangent functions in this recording. In Odyssey, where we have three different units that are, we'll be studying trigonometry functions. There'll be the sine ratio, cosine ratio, and tangent ratio. Since they are so similar, I'm going to be covering all three units, or I should say all three lessons in the unit in this one recording. As you can see that we have abbreviations for the words sine, cosine, and tangent. For the sine, we have it listed as SIN, which is listed there in green. We have COS, which stands for cosine, which is abbreviated in orange, and TAN for tangent, abbreviated in purple. Again, I'm sure you've seen these before. It's just an easier way for us to write it rather than the whole word. When we talk about sine, cosine, and tangent, there's some characteristics that we have to think about when we're looking at our triangles. In order to use these trig functions, they have to be right triangles. It cannot be an equilateral triangle because all those angles have the exact same measurement. They are all 60-degree angles. All sides have the exact same length. So we would not use sine, cosine, tangent for an equilateral triangle. We would not use it for an acute or an obtuse triangle. An acute triangle has your angles that are, all three of them are less than 90 degrees. The obtuse triangle has one angle that's larger than 90 degrees. Okay, so we have to have a right triangle when we're talking about sine, cosine, and sine, cosine, tangent trig functions. You may recall that we used the Pythagorean theorem for right triangles as well. Now, one thing to remember for the Pythagorean theorem is we were looking just at the outside measurements of a triangle, just the lengths, the different legs, the hypotenuse. With our trig functions, we're going to be using a side or an angle in order to help us determine the missing either leg or angle. We use this by something called ratios. And, you know, before you panic and like freak out what about ratios, they're basically just fractions. And I know that doesn't comfort a lot of people either.
All right.
This little chart just gives you an idea of like when you should be using Pythagorean theorem versus your trig functions. Okay, and if you look at the pictures, you can see that, you know, for our right triangle, we're given two legs of the triangle, and we're looking for the third one. If you look on the right side there, you can see that we have an angle measurement there. In this particular picture, there it's 37 degrees, that little angle in blue. So we're given an angle, and we have a side, and then we can find the next side. Okay, so it's just kind of a way, like, you know, which formula should you be using depending on what the question is asking for. Again, in this section, we're going to be using what we call our trig functions, sine, cosine, and tangent. And you'll notice that in the boxes there, I have a green box, an orange box, and a purple box. Okay, these are the ratios that I had mentioned earlier that we will be using when we're looking for the leg or an angle measurement, depending on what information is provided to us. You'll see that the green box, we have the sine of b, where b would be your angle, and it's going to be the fraction or the ratio, opposite over hypotenuse. For cosine, it would be adjacent over hypotenuse, and for tangent, it would be opposite over adjacent. You could see each of these listed there. Now, it gets really confusing, like, you know, which one do I use when? Well, we have something called an acronym, and you may have heard this acronym before. We say SohCahToa. Okay, you see it down there. I have it pronounced down there in the blue, SohCahToa, and that's to help us identify which ratio we should be using. Now, I know what you're going to say. SohCahToa almost sounds like something here in history, right? Sacagawea, the Indians, and, you know, it's again, this is something to help us remember how to use the trig functions. It's not an Indian in this case. So if we look at the green box, you'll see that that starts with the S. The green S represents the green box. So that means that we're going to be using the sine. And the OH is your opposite over hypotenuse. You'll see the O is on next to the S. which is going to be your numerator, and your h is going to be your hypotenuse, which is a denominator. So by just remembering this acronym SohCahToa, you are actually learning the different ratios for each of the trig functions.
And that's all over x.
Getting rid of all that purple, green, and orange, purple stuff, you know, just trying to keep it simple here. If you look at your different triangles, you can see that it depends on what information is given to us and when we go to use our sine, cosine, or tangent. So by getting rid of all the colors, this is a pretty basic picture. If you're given angle B and you're given either the opposite or the hypotenuse of the triangle, then you're going to be using the sine. Now if I look at the middle picture where I'm looking at my angle B and I'm given the adjacent and the hypotenuse, you can see the adjacent is a different position than the opposite as it relates to my angle B. I have another slide that I'm going to show you where I kind of break it down even further to give you a better idea of how you're labeling your pictures. All right, if I were given this right triangle, you can see that I have some information that's already labeled in this triangle. It's a right triangle because you can see that little square box in the corner. Okay, so that's just one of the ways I don't have to label it as 90 by having that little box there that identifies it as a 90-degree angle. We have to determine which trig function we're going to be using because we are giving one angle and one side and my one unknown, which is my variable y. I'm going to try and solve for y. So in this particular case, I'm looking for the leg of my triangle. Looking at labeling my picture here, I know that the side opposite of my right angle is my hypotenuse. The reason I know that is that's going to be my longest side because my right angle is going to be my largest angle. So my hypotenuse will be across from the right angle. Again, it will always be the longest side. Do you hear me stressing always? Always, always, always. Okay. I'm looking at my angle measurement of 50 degrees. That's going to determine my other two legs. We can easily identify the hypotenuse. So it's the other two legs I have to figure out which one's the opposite and which one's the adjacent. It's all going to be based on where my angle is. Since there I labeled it as 50 degrees, that one angle at the top of the triangle, you can see that my opposite side is what's labeled as y. Now how can I determine that's my opposite? What I'd like you to do is imagine that you're standing there in the corner where it's 50 degrees and you have a flashlight and you flip that flashlight on to shine it across the room. Well, your flashlight, the light beam that's shining across the opposite of you, okay, is lighting up that wall. That's going to be your opposite side. So just remember, like you're standing there in the corner, put that flashlight on. What am I shining on? That's going to be your opposite side. So in this particular picture, the side that's across from my 50-degree angles is my leg Y. Now the other leg that is not labeled there would be my adjacent leg. And my adjacent means that it's next to. And if you look at that, you can see where the 50 degrees is. And part of my 50-degree angle is that leg. So it's kind of, that leg is next to my angle. That would be your adjacent leg. So now I have my picture here. I have my right angle, and I know which is my hypotenuse, which is my opposite leg, and which is my adjacent leg. I'm ready to go ahead and start solving this particular problem. So we're labeling 10 as my hypotenuse. I'm labeling y as my opposite. Now I have to determine which trig function I'm going to use in order to solve this problem. I'm going to go look at my acronym there, my SohCahToa, I was about to say SohCahToa, to determine which trig function I'm going to use. Looking up there, I have opposite and hypotenuse, which means I have OH. Since I have OH, that means I'm going to be using my sine. So to set up my equation here, I know I'm going to take the sine of 50 degrees is going to equal y over 10. Remember, it's my opposite, which is my numerator, over my hypotenuse. The angle measurement always goes with your trig function. So your degrees will be with your sine, cosine, or tangent. Now what we're going to do is we're going to actually go into your Odyssey Ware lesson, and you'll see you'll have a chart there, a table of trigonometric ratios. Okay, this is a very, very long table. I have it, just a portion of it here on the screen. And as you can see, looking at the headers, you have a column labeled angle, and you have a column labeled sine, cosine, and tangent. Okay, so because I'm taking the sine of 50 degrees, I'm going to go find my column that says sine, and I'm going to go find the one that has an angle listed as 50 degrees. Now you can see there's two, I guess they broke this down rather than going from 1 to 90 on the like, you know, one column all the way down. They actually split it into two. So you can see, like, you know, on the right hand side, the set, you know, you'll find that's where my 50 will be. So what I'm going to do is I'm going to come down there and I'm going to say 50 degrees, and when I look at my sine, you'll see that the value I'm getting is 0.7660. So instead of writing sine 50, I'm actually going to put that decimal into my equation. Now I'm going to stress here for those Odyssey Ware students, because Ingenuity, you will have the same type of problem, but they don't provide you with the table as far as I remember. Okay, but for Odyssey Ware, absolutely use the table. You can use a calculator, but the calculator is going to go out to as many digits as your calculator can. If your calculator goes out to 8 digits, you know, if you go on the computer, it may go out to 12 digits. Okay, trust me when I say use the table for the Odyssey Ware folks. The reason I'm saying that is because you'll have a rounding issue. Look how close those numbers are. You know, the further you get out, the more numbers you're going to have there, and they're going to be closer. So like looking at 46 degrees versus 47 degrees, you know, they're very close. And as you go to do your calculations, you could be off a number, but it's only because you used the wrong decimal. Okay, it's really important. I guess, can you hear that? I'm stressing. Use the chart. Okay, so now we substitute in, instead of sine 50, we put in a 0.766, and everything else stays the same, equals y over 10. At this point, we just need to solve for y, and by doing that, we multiply both sides by 10, and our final answer for y will be 7.66. This makes sense because we know that our hypotenuse is 10. My value, my leg, whether it be my opposite leg or adjacent leg, has to be less than 10, because we know that 10 is going to be the longest side in our triangle. So when you get an answer, make sure it makes sense. Look back to say, okay, this is a leg. Is this number less than my hypotenuse? Here we have another problem. Again, it's already out there, it's solved for you, but I wanted to show you that here I'm looking for my angle measurement. I'm giving you two sides of my triangle. Now, again, I know I'm using my trig functions because I'm looking for an angle measurement. Pythagorean theorem would only be looking for the measurement of another side of my triangle. Okay, so again, we know that we're using our trig functions. Everything is still set up the same. I know which is my hypotenuse because it's going to be my longest side. It's across from my right angle, so I know my hypotenuse is 5. I'm looking at where my angle is. My angle is in the bottom right-hand corner labeled as x. Across from x is the other side that's labeled. That side is my opposite side. With that opposite side, I know that I'm going to be setting up my ratio. Sine is opposite over hypotenuse. That means I'm going to put 3 over 5, and I'm looking for my angle measurement. So I'm going to put in my calculator 3 divided by 5, and I'm going to get 0.6. At this point now, I still have to go back to my table. I'm going to go back and look in my sine column, and I'm going to be looking for a number that's going to be close to 0.6. Now on your calculator, it may come out just to be 0.6. Okay, but if you look at our table, it goes out 4 decimal places. That's okay. We can just add the zeros on the end. It's not going to change the value of our number. We're going to go into our sine column. We're going to keep looking to see what we get, what number we find that's going to be as close to 0.6 as we can. You can see down there in the pink box, I have 3 numbers that are highlighted there. the one that's closest to 0.6 is going to be that 0.6018.
All right, so I'm going to write this down.
And that tells me that my angle measurement will be 37 degrees. Now, very rarely are you going to see one that the ratio is going to be exactly the same number that's in our table, that 4-digit decimal number. Okay, so again, you're going to have to see which is the closest, and you may have to subtract, 0.6 minus 0.5878, 0.6 minus 6157 to find which is the smallest number. In this case, you can see it's 0.0018 is going to be the difference between what I got for a 3 or 5 and what my angle measurement is. Okay. I'm trying to remember in Odyssey where if they would give you an answer that would be 36, 37, 38, and I'm racking my brains and I'm almost positive they wouldn't do that. I'm pretty sure they would say like 30 degrees and they give you 37 and they might give you 41. Something that would be close, but not something that's honestly 1 degree different. I think that they understand that, with the rounding, somebody might have picked 36 degrees or someone might have picked 38. And I don't think they would try and trick you in that respect. For your state tests, if you can show your work on open-ended questions, I'm sure they would allow for a little bit of a leeway with rounding. So just be careful. As far as Odysseyware, though, once again, they're going to just give you the one answer, and you're going to have to figure out which one that is. Use the chart. It's going to be your best solution. Okay, here's another right angle. Okay, I have an angle labeled as 20 degrees. I have a side that's listed as 5. I have another side that is an X. I know I'm using my trig function. I have to label my picture first before I can determine which trig function I need to use. What I have here is the hypotenuse, which is my longest side. It's opposite my right angle. I have my angle measurement, and when I look at my angle measurement, I see the side X is part of my angle measurement. It's right next to it. So I know I have my adjacent side. So I have my adjacent and my hypotenuse. Because I have my adjacent, my hypotenuse, I know that I'm going to be using cosine. I'm following the Ka rule, so to speak, of the of SohCahToa. Okay, I have my adjacent and my hypotenuse. Again, I'm going to set up the same formula up by same ratio where I have now I'm using the cosine. I'm giving my angle measurement of 20 degrees. I know my adjacent side is X and my denominator, which is my hypotenuse, is 5. Going to my table, looking under cosine, which would be in the second column because it's sine, cosine, tangent. Looking to see what the cosine of 20 degrees is. I have my decimal. And now I'm going to solve for X. Multiplying both sides by 5 will get me the 4.6985. You'll notice that this is the exact same formula or the same setup, looks the same as my sine ratio that we set up before, except one time we use sine, one time we use cosine. It all depends on the information that's given to you in the triangles. Here you can see the triangles. 50 is on the opposite side, y is on the opposite side of my 50. X is next to my angle that's labeled 20 degrees. So we can see how it depends on where or which angle they're giving us for us to determine the other leg. Is it next to it or is it across from it? Hypotenuse is easy. Okay. Again, another example here where we're looking for an angle measurement when we're given two sides. Again, we know we're using our trig functions. My leg that is labeled with an 8 is next to my angle, so I know I need to use cosine. Okay, so now I'm looking for, in the cosine column, for a number that's close to 0.6666. And you can just imagine it's going 66666 all the way out if you put it into a calculator. Okay, looking for that, the one number that's closest to that would be 48 degrees. So now I know the angle measurement is 48 degrees. The last one,
Let's see.
tangent. Here I am not given the hypotenuse. I'm working with both legs. In this picture here, I see I have angle A that's on the bottom left-hand corner. Okay, I know that my hypotenuse is not labeled. There's nothing on that side, so I can see what my opposite side is compared to my adjacent side in relation to angle A. So in this particular case, SohCahToa, that means it's my opposite over my adjacent. In this particular problem, I'm looking for my adjacent side. I'm looking for the side that's next to 30 degrees. So when I put this into my formula, and look how the formula looks the same. I have the tangent of my angle measurement is going to equal my opposite over my adjacent. Opposite, it has a length of 6. My adjacent side is an x. In our table, tangent of 30 degrees would come out to be 0.5774. Now this one was a little bit tricky because my variable was in the denominator. So in order to clear my denominator, I had to multiply both sides by x. And then my equation became 0.5774x equals 6. So I have one more step to do where I then had to divide 6 by my decimal 0.5774 in order to find my value of x. Now in this particular case, when we're looking for our leg measurements, we don't have that eye check with the hypotenuse because we don't know what the hypotenuse is. We could figure it out now that we know that what our adjacent leg is, but that's not what this problem's asking. Okay, so when I'm trying to compare my opposite leg to my adjacent leg, you know, we'll never know if one leg's supposed to be larger than the other because we can't always rely on our figure. In this one, it looks like our figure where the variable x is larger. But sometimes it's just a hand-drawn picture and, you know, we can't really tell how accurate it is. Okay. Once again, another problem where we're looking for the angle measurement, but we are given our opposite and adjacent sides. Again, we see that our adjacent side is our 4, which is next to angle x, and across from angle x is our opposite side, which is 6. Looking at this information, I'd have 6 divided by 4 will give me 1.5. Again, I added some extra zeros at the end just to make it easier on my eye, train my eye to look in that chart. So I'm going into the last column where it's tangent, looking for something that's close to 1.5. And the closest that I get to is the one that's labeled as 57 degrees. So now you have SohCahToa, or SpongeBob, and I'm sure you can hear him say it, SohCahToa. Okay, something that we're looking at for right angles, sine, cosine, and tangent. This covers 3 lessons in our geometry course. Hopefully, it's painfully obvious now how we are going to be using these equations. It's not difficult. The format, the pattern is the same. You just need to have your problem set up correctly. Again, number 1 rule is label your picture first before you just start throwing some numbers into your equation. Okay. Once you have your information in the equation, it's, you know, you're going to read your chart and run from there. If you have any questions whatsoever about this section, the SohCahToa, okay, which is your sine, cosine, tangent, please come visit me, come into the virtual office. You can send me an email. You can send me an email on OdysseyWare. You can call me. I will absolutely love to go over this with you. If you have any ideas of something else that you want me to go over to create a presentation, please let me know. I am open to suggestions. That is it for today. I hope you enjoyed our SohCahToa lesson, which is otherwise known as SohCahToa. Have a great day. Bye.
All right. Now your last question is